sensors have been classified into a lot of categories. Is someone saying something? Okay, I'm continuing them. So sensors have been classified into a lot of categories by various authors and experts. So instead of focusing on all the classifications we are focusing here on only the three basic general classifications. First, the active and passive sensor. Second, the digital and analog sensor. Third, on the basis of the input and output. See, in active and passive sensors, active sensors require an external excitation or power, whereas passive sensors don't. If I were to give an example, we can take an example of an active and passive infrared sensor. An active infrared sensor emits and detects the infrared radiation, whereas the passive infrared sensor only detects the radiation. And if I were to say that the infrared emitter has a receiver and an LED in it, whereas the passive infrared sensor only has a receiver. It does not emit the infrared radiation, it just receives them. So the passive infrared sensors, they don't detect an object's specific location. They just tell that an object or a person is around. Whereas with infrared sensor, we can also detect an object's specific location.
Ma'am?
Yes.
So means active sensors, we can say sonar.
Yes.
Is a type of active sensor.
Yeah, we can say that.
And metal detectors are a type of passive, which just detects that there is a metal something.
Yes.
Okay, understood.
Okay. You can just call me by my name. You don't have to call me ma'am or anything. And Ayati, will we begin the recording of this session for reference? I'll get back to you in a little bit.
Okay? Yeah, we'll upload it on our YouTube channel. You can refer it through.
Okay, so you can go through that also. Okay.
Thank you.
Okay, yeah, you're welcome. So the second type of sensor is digital and analog sensors. So as the name suggests, analog sensors produce an analog output, that is a continuous output signal with respect to the quantity being measured. Like we can take a few examples of accelerometer, the light sensors, the pressure sensors. So we give them as most of these sensors which we'll consider are generally analog sensors like temperature, light sensors, pressure sensors. And in contrast to analog sensor, the digital sensors work with discrete or digital data. We'll discuss further in the presentation. We have an analog temperature sensor and a digital sensor. Then on the basis of input and output, we have like the type of conversion that takes place. For example, a photoelectric sensor or a thermoelectric sensor converting photo energy to electrical energy, thermal energy to electrical energy, and so on. I hope it's all right. And you guys have any questions? Like if you guys just ask their questions. So till now, we were talking about what are sensors. So can you guys list out a few parameters which we must keep in mind while choosing sensors? Like I have listed out a few. Like could you tell me anything else?
The type of communication protocol they use.
Okay.
Cost.
Yes. Sorry.
Cost.
Yes. Cost. Yes. Yes. And
Durability of the sensor.
yeah. Okay. Correct.
Yeah, portability.
Yes.
How accurate they are.
Yes. The accuracy of the sensor. Correct.
Delay in the response time.
Yes. Okay. So I have listed out a few parameters which one should keep in mind while choosing a sensor. Since we know that sensors don't work on their own, and for their working, they need to be connected to some electronic components like a microcontroller. So we must know how to choose sensors. Here, Is someone saying something? Okay, I'll continue then. So here I have listed out a few basic parameters for choosing the sensors. First would be the type of sensing. See, if I want to measure temperature, I'll go for a temperature sensor. If I were to measure pressure, I'll go for pressure sensors. Now within those sensors, we have various categories. For like temperature sensors, you have an analog sensor which just measures the temperature. Then we have another sensor which measures temperature and humidity. So we need to keep in mind what criteria, what we are measuring for taking the apt sensor. Second would be the power consumption. It's really important because the power consumed by a sensor plays a very important role in defining the total power of the system. The power supply to the sensor should always be kept under check because if the sensor or the controller are not in accordance with the required criteria, we may end up destroying our sensor and microcontroller board. Then we need to keep in mind the environmental conditions, as someone just said, the accuracy of the sensor and resolution and range of the sensor. Hope I'm not going too fast and you all are able to catch up with me. If whenever you feel like I'm going too fast, just tell me, okay? So till now, we saw what are sensors, classification of sensors, and how to choose a sensor. Now, let's have a look at the different types of sensors. First of all, we'll go through a temperature sensor. So, as the name suggests, temperature sensors are used to determine the ambient room temperature and can also be used to determine our body temperature. Now, there are various kinds of temperature sensors. As we'll see in the next few slides, we have the TMP36 sensor, the DHT11 sensor, and the MLX90614 infrared temperature sensor. Starting off with the TMP36 temperature sensor, this is the first temperature sensor which we are considering. The TMP36 is a low voltage precision centigrade temperature sensor. This temperature sensor, unlike other temperature sensors, doesn't use mercury or bimetallic strip or thermistors. Now, what are thermistors? These are temperature sensitive resistors. They are basically semiconductors with their insulating proper conductivity, resistance lower than the conductors but higher than insulator. The thermistors change their resistance according to temperature. So these are not used for temperature sensor, but the working principle of TMP36 is the voltage across the diode terminals. The temperature change is directly proportional to the diode's resistance. We have a diode within this temperature sensor, so the working depends upon the voltage across those diode terminals. So the cooler the temperature, lesser will be the resistance and vice versa. Here, we can see a pinout diagram of TMP36. I'm just showing you the pinout diagram right now. Later on, Aditya will show you how to connect it with the Arduino and see it's working as well. So here we have a power pin, an output pin, and a ground pin. The power pin needs to be connected to the power supply in the Arduino board, which can be anywhere from 2.7 to 5.5. Then the ground pin needs to be connected to the ground of the Arduino. Any doubts till now? Any questions?
The name of the sensors, are these the technical name or just the product name made by the company?
These are generally the product names which I have included. You can find these names on a data sheet which the sensors have with them. I have included those names in the presentation.
So, ma'am, the values like you said TPM 36, those
Yes.
36, do they have any significance?
As far as I know, see, there are various sensors like LM. You will find various sensors, okay, like LM35, LM355, TMP36, DHT11, DHT22.
Huh.
So I'm not very well aware of what the number stands for.
Okay.
I'll get to you at the end of the session if I find it. Okay, will
Okay,
that be
ma'am.
all right?
Yes, ma'am. No problem.
Okay. So before going on with the DHT11 module, let's have a look at the humidity sensor. As the name suggests, humidity sensors are used to measure the humidity in its environment, and it converts its findings into electrical signal. We can find humidity sensors in handheld devices such as smartphones. You all must have seen in the weather app of your smartphone, you can see the moisture content along with the temperature. If you guys ever paid attention, you'll see the humidity content as well. You can also find humidity sensors in large embedded systems. So here we can see a humidity sensor. It has two electrodes, the upper electrode and the lower electrode, with a moisture holding substrate sandwiched between them. So what exactly happens is the ions released by the substrate as water vapor. When there's moisture around, this moisture holding substrate, as we can understand from the name, absorbs the moisture. When it absorbs the moisture, it releases ions. And we know as ions are released, there will be increased conductivity between these two electrodes, thus reducing the resistance. So we can understand if the humidity is high, more water vapor will be absorbed, lower will be the resistance, higher will be the conductivity. So if I were to say higher relative humidity decreases the resistance between the electrodes. Okay. So why I explained humidity sensor was because the DHT11 temperature sensor, along with measuring temperature, measures humidity as well. So just like I said, like the TMT36 works on the voltage difference between the diodes. Various temperature sensors have various working, such as this DHT11 works along, measures temperature with this thermistor, and has a humidity sensing component, which I just explained. Thermistor, I explained, it changes its resistance according to the temperature. So we can see how a DHT11 looks like. If I were to open a DHT11, we'll see this and the moisture holding substrate, the humidity sensing component. So inside the DHT11, we'll see a Ntc thermistor. Ntc, now what's Ntc? Ntc stands for negative temperature coefficient. That means when the temperature increases, the resistance decreases. There are generally two types of thermistors, TTC and NTC. But in most of the cases, we use an NTC thermistor. The graph works like this. TTC stands for positive temperature coefficient. That means as temperature increases, the resistance also increases. But here we are going with the NTC curve. In the DHT11, okay, so I forgot to mention one thing. The TMT36 is an analog sensor, whereas the DHT11 is a digital sensor. I haven't included that pic, but if you were to see, the DHT11 sensor has a very basic chip inside that does some analog to digital conversion and gives out a digital signal with the temperature and humidity. Okay. So here we can see the pinout diagram of DHT11. Similar to TMT36, there are 3 pins: the power pin, the output pin, and the ground pin. Power pin connect to the power supply from the Arduino. The output pin acts as a communication between sensor and the Arduino, and the ground pin needs to be connected to the Arduino. It may seem complicated a little bit right now because I'm only showing the pinout diagram, but just wait till the end of the session. Aditya will explain you everything. So just stay tuned till then. Okay. I hope everything's fine till now. If you have any questions, you can ask.
I'm still not clear with the digital and the analog sensors.
Okay, so what the difference is between the components present within the sensor. Usually in the digital sensor, you'll find an integrated chip with the sensor, which does the analog to digital conversion. In analog sensor, you won't find an extra component. I did not include the picture, but if you Google it up, you'll see that this DHT11 at the back end, there's an 8-bit chip which does the digital analog to digital conversion. Whereas generally these temperature sensors, they're simple to look. They don't have much in it. It's basically the how they're made, the components present within them. Is it okay now?
Yeah, but then if you are converting analog data to digital, then isn't the analog more efficient? You don't need to do an extra step.
See, what happens is what we are going with. In a few projects, the analog might be more beneficial, but in few projects, the digital would be more easier. So it depends from project to project and what you're trying to measure. If see, in DHT11, we measure the temperature and the humidity, whereas in analog, we just measure the temperature. So it depends on what you're trying to measure. Is it okay?
Yeah, that'll be right.
Ma'am, what is widely used?
The digital, see, in basic projects, you can see, like, if you were to start with the projects right now, you'll start with the analog sensors, but digital are also being used very widely. If you were to go like with more advanced projects, you'll start working with digital sensors. You'll start with analog, but then move on to digital. So it works that way. Okay, so moving on to another type of sensors, we have light sensors with us. Light sensor, as the name suggests, it's a device that converts light energy, whether visible or the infrared parts of the spectrum, into an electrical signal output. There are generally two types of light sensors: photoelectric devices, photovoltaic or photoemissive, and the other are photoresistors or photoconductors. Light sensors are also known as photoelectric devices or photosensors because they convert light energy into electricity. Starting off with the very first sensor, the LDR sensor. It's a very basic sensor. The LDR sensors vary their resistance according to the light falling onto them. They're also known as photoresistors. Photoresistors, like these resistors, are used to simply detect whether a light is on or off and compare relative light levels throughout a day. The photoresistors are made up of high resistance semiconductor material called cadmium sulfide cells, which are highly sensitive to visible and near infrared light. As we can see, there are two pins. They can be easily interfaced with the microcontroller board, the Arduino board, which you'll see later on. But how do the photoresistors work? As the name suggests, photoresistors work similarly to regular resistors, but instead their resistance, as I told before, their resistance changes. That is, their resistance depends on the amount of light falling onto them. We can see from the graph from here, more is the intensity, lower is the resistance. Lower is the intensity, higher is the resistance. High intensity of light causes a lower resistance between the cadmium sulfide cells. The LDR sensors also find their use in few street lamps. Like during bright time, during daylight, the sensors are turned off, and during nighttime, the sensors are turned on. They sense. Moving on to another type of light sensor, we have photodiodes. So as I said, different sensors have different kinds of working. Like LDR worked on how much sunlight was falling onto it, photodiodes work on the inner photoelectric effect. We all know what photoelectric effect is. That is, when a beam of light hits, electrons are loosened, causing electron holes, which results in electrical current to flow through. We can find That means the brighter the light present, stronger the electric current will be. We all have studied what photoelectric effect is previously, so that's how the photodiodes work, opposed to the working of LDRs. We can find the use of photodiodes from compact displays to smoke detectors, solar panels, and remote control devices. So till now, we have seen the temperature sensors, light sensors, and the humidity sensor. Lastly, we'll be taking on the ultrasonic sensor. Any doubts, any questions till now?
How are they used in smoke detectors?
The usage in smoke detectors. Okay. Can I get back to you later on?
Yes, ma'am.
Okay, sure. I'll get back to you surely. Okay.
Yes.
Okay. So the last sensor which we are taking is the ultrasonic sensor. As we can see, the ultrasonic sensor has two components, the transmitter and a receiver. You may not see the T and R written over here, but if you were to see the ultrasonic sensors in real life, you'll see a capital letter T written near the transmitter and a capital letter R written near the receiver. We can see that there are 4 pins. The pinout diagram has 4 pins. One connected to the power supply. Trigger pin is used to trigger the ultrasonic sound pulses. The echo pin, it produces a pulse when the reflected signal is received, and the ground, which is connected to the ground of the Arduino. Before ending, let's have a look at how do ultrasonic sensors work. So there are 2 cases. First, when there's no obstruction. Second, when there's an obstacle. So as let go to the previous slide once. See, the transmitter and the receiver. The role of the transmitter is that it converts electrical signal into 40 kilohertz ultrasonic sound pulses. Now, what's the role of the receiver? The receiver listens for the transmitted pulses. It listens for the transmitted pulses. If it receives them, it produces an output pulse whose width can be used to determine the distance the pulse has traveled. Let me say it again. The receiver listens for the transmitted pulses. It may receive, it may not receive. But if it receives the pulse, the width can be determined. It used to determine the distance the pulse has traveled. Now, how does it mention? Okay, so if I were to show you the ultrasonic sensor, this is a crystal oscillator. It measures the time, the signal which was given out by the transmitter, how the time taken by the signal to come back to the receiver. Okay. See, the circuitry inbuilt on the module, like I said, the crystal oscillator, it calculates the time taken for the ultrasound to come back and turns on the echo pin. This is the echo pin. It turns on the echo pin high for that same particular amount of time taken. So we have due to the crystal oscillator, it determines the time which the ultrasound will take for it to come back. So there are 2 cases. The ultrasonic pulse may come back, it may not come back. The width of the pulse, you can see the width of this pulse, it's different. It's 38 millisecond over here. It's 500 microsecond over here. The width of the pulse varies and depends upon the time the signal took to be received. Here, in this case, the signal is not received back. Here, the signal is received back. In case the pulses are not reflected back, then the echo pin, I show you the echo pin. The echo pin will time out after 38 milliseconds and return low. You may you may find it a little bit complicated, but Aditya will explain you, and with a little bit more research, you'll get to know it, you'll understand it better. So this 38 millisecond pulse, it indicates that there's no obstruction within the range of the sensor. But if we were to see an obstacle, if there's an obstacle, a pulse is received back. So in that case, the ultrasonic sensor, it calculates the distance present between the ultrasonic sensor and the obstacle. We can also calculate it with the simple relation of distance equals to speed into time. We know the speed with which sound travels. You can take it 330 to 340. Then convert it into centimeter per microsecond, because the time over here is 500 microsecond. So distance would be speed into time. Time is this 500 microsecond. But that will not give us the answer. For getting the exact answer, we'll have to divide it by 2. Why? Why will you divide it by 2? Because the time is how much the time taken by the signal to go out, strike this obstacle, and come back. That will give us a distance. So that is how the ultrasonic sensor measures the distance between the obstacle and the ultrasonic sensor. So with this, I'll stop the presentation, and Aditya will continue the session by explaining you how these sensors can be connected, and you can see the working of it. Thank you. So Aditya?
Yeah. So before we move on to the next part, I just want a raise of hands as to who has TinkerCAD, who has experience with TinkerCAD or has an account created on it. Just raise your hand if you have already.
Can you
worked
repeat
on
what
it.
you said?
There's a website called TinkerCAD. If someone has worked on it before or already has an account on it, please raise your hand. If you've not heard the name, it's fine. I'll just guide you through it. Okay. So the people who already have it installed can just take a small break of 5 minutes. The people who haven't created an account on TinkerCAD, so would one of you volunteer to share your screen? Anyone who doesn't have an account on TinkerCAD?
Yeah, I am willing to show.
Okay, yeah, share your screen. Yeah, click on TinkerCAD. Click on join now. I want everyone else who doesn't have an account yet to follow this. If you want me to slow down, please say so. And yeah, Archit. Next, click on create a personal account. Yeah, and you can sign up with your email or sign in with Google as per your wish.
I had a question.
Yes.
Yeah, what is the use of what are we using TinkerCAD for?
We'll be simulating the sensors and programming the Arduino on it to get real-time results.
Okay.
I mean, because we can't expect everyone to have physical sensors, right? So we use this software to simulate it. Yeah, just you can like stop sharing your screen. And once you're done creating your account, you can share it again. If anyone has any problem in creating an account, please let me know and you can share your screen.
Is it possible to download TinkerCAD or is it?
No, it is on. It's on. It's an online thing.
Okay, okay.
Yeah, it's on the browser. Yeah, yeah. You can. Yeah. So everyone, make sure you're on the screen right now, and I'll take over from here. Archit. Thanks a lot for sharing and volunteering. So I hope everyone is on the screen right now. Yes, in the chat box, or unmute yourself and say yes. That'll be enough. And who all are still installing it can raise your hands. I'll wait till then. And who all are still creating an account, you can raise your hands. I'll wait for you. Yeah. Okay.
Yes, students.
Yeah. I told who all are still installing, you can, I mean, who all are still creating an account, you can raise your hand. Who all have already created an account can lower your hand.
Is TinkerCAD and simulation of some sort?
Yes, it is a simulation software where
Uh,
you can simulate, you get an Arduino Uno there, which you can program, and you can also use sensors there.
okay, so we can use Arduino, and this is the main difference between TinkerCAD and Multisim.
I'm not sure if multi-sensor, but I've been using TinkerCAD, and yeah, it's only limited to Arduino Uno, and it gives, and it's easy to visualize basically.
Multisim, you generally use it for the electronic circuit. This TinkerCAD, you mostly use it for Arduino programming.
Okay, is everyone done creating an account on TinkerCAD? Shaurya and Roshan?
Yeah, I'm doing it.
Yes,
Yeah.
sir, done.
Okay.
Yes, sir, done it.
So once you're in the screen, click on circuits and click on create new circuit. It'll be empty for you. These are few of my previous projects. So you can just click on create new circuit. If I'm going too fast or you need me to stop, please let me know. So once you click on create new circuit, you'll be brought to this page. You can see a bunch of components on the right hand side of the screen. As well, if you click here, you'll find out basic starter kits, which I suggest you to go through after this session. They're really helpful, and they also provide you with the code so that you can start learning. But for the purposes of this session, we'll be taking individual components and making the circuit ourselves. So is everyone on the screen?
Yes.
Okay. So the first simulation we'll be doing will be with the ultrasonic sensor. And what we'll be doing is measuring the distance of an object from the sensor. So for this, in the search bar, type Uno or Arduino, and you'll find the Arduino Uno will appear below. Click on it and drag it into the screen. Now, before we continue, I want to know how many of you know what an Arduino Uno is? Okay, Debangan, you can unmute yourself and say.
I mean, I know what an Arduino is. I'm not exactly sure about the Uno part.
Okay, you can tell me in general itself. What's an Arduino?
Well, an Arduino is like a pre-built circuit where you can program for your whatever project you're using it for.
Yeah.
Instead
Okay.
of coding a PCB from the scratch, an Arduino gives you a better place to start.
Yeah, right. So
It's a
the
mini
proper
computer.
definition, I mean, yeah, correct. So the proper definition would be a microcontroller based board, okay? And it is based on the Atmega 328P, which is this thing here, okay? So it's actually a microcontroller board based on the Atmega 328P. I suggest you Google the Atmega 328P as you'll get a lot of insights into microcontrollers. And the Arduino Uno has 14 digital pins and 6 analog pins. And the ones written with a wavy curve on the digital side are PWM pins or pulse width modulation pins, which help convert digital signals to analog signals. But for the purposes of this session, I won't be discussing them, but I highly recommend you go and look into PWM after this session. Okay, now did everyone bring in an Uno to their workspace?
Yes.
Okay, so the next component we require is the ultrasonic sensor. So type ultrasonic in the search bar. And here you'll find two of them, a 3-pin one and the 4-pin one. The one Prakriti explained was the HC-SR04 sensor, which is a 4-pin one, and I'll be using the same for this session. So like how you dragged out the Uno, drag the sensor out also. So these are all the components we'll be requiring for this basic project. So now we need to start connecting the ultrasonic sensor to our Arduino. So to do this, we just click on the pin out, and you can see as soon as I go there, it tells us what this pin is. So the VCC or the power pin is usually of the sensor is usually connected to the 5-volt pin of the Arduino Uno, meaning it just takes in power. So we connect the VCC pin to the 5-volt pin by first you click on it and drag your mouse downwards. If you want to make a turn, click on the screen again and you can make a turn. And we bring it to the 5-volt pin on the Arduino. This is a 5-volt
Exactly the
pin.
5-volt pin.
You can use the 3.3-volt pin or the 5-volt pin, but the like these are the power supplies on the board itself. So when you remove it, I mean, yeah, so it gives the power directly from the board itself instead of you connecting it to some other external power source. So the 5-volt and 3.3-volt are power supplies given by the board itself. So you can use either 5-volt or 3.3-volt. The particular code I'll be using is for 5-volt, so I'll be following that itself. So is everyone done connecting the VCC to the 5-volt?
Yes.
Okay. Now we connect the trigger pin. As Prakriti explained, the trigger pin is the one which sends out the ultrasonic wave. And yeah, it basically starts the ultrasonic wave from the sensor. So we connect that to the digital pin 3. As this is a digital sensor, we'll be connecting it to the digital pin on the Arduino. So we connect it to pin 3. And as per convention, I'll be following power pin as a red wire, which can be changed here. You don't have to follow it. I'm just keeping it like that. Okay, so connect the trigger pin to your digital pin 3. When you're done with that, please say yes.
How do you change the color?
Oh yeah. So choose the wire, and then on the left hand side top, there's the wire color option where you can choose the wire color. Got it?
Yeah, got it.
Yeah. Okay.
Yeah, why we connected ultra board to -3?
It's not -3. It's just 3 with the wavy symbol represents that it can do pulse width modulation. So yeah, about why we are connecting it to pin 3, there's no requirement as such. You can connect it to whichever digital pin you want. I've written the code such that it'll be used in digital pin 3, but there's no necessity as such. And when I do the coding part, I'll tell you why I'm connecting it to digital pin 3. But there's no specification as such. You can connect it to any of the 14 digital pins available. So if you do connect it to something else, while I'm explaining the code, you'll just have to make a small change. You'll just have to change the number 3 into something else, whichever pin you're connected to.
Okay.
Yeah. So if everyone's done connecting the trigger pin to pin 3, I'd like you to connect the echo pin to the digital pin 2 of the Arduino. So the echo pin is tells the Arduino when we've received the ultrasonic wave back. And I'll be giving it a different color. And the last pin we'll be left with is the ground. So ground will be connected to any of the 3 grounds available on the Arduino. As you can see, there's 3 grounds available. You can connect it to whichever one you want. So once you're done connecting the components, or if you're facing any issue while connecting the components, please let me know.
The Arduino has one more ground pin, which is there in the pin form where on is written. The Uno.
Yeah.
In the actual Uno, the physical Uno, there are some pins beside that on which is written beside the processor.
Over here?
Yeah. There's
No, I can show you the real pin and there's nothing there. I can show you the real Arduino Uno and there's nothing there.
Okay.
Yeah, there is nothing on the on pin. The on is just an LED to let us know that.
No, beside that on there.
Yeah, there's nothing there. There's usually nothing there.
Yeah, there is the ICSP header. It's basically used for debugging. So there's no need to connect anything to that.
About this microcontroller, does this gets does it gets a full redesign every few years, or is it just constant? Like if I talk about Arduino, I will get this one only, Arduino Uno.
No, there are several models available and each of them keep being updated with the communication protocols necessary as well. And there's also Raspberry Pi if you want to do more advanced projects. So there's each microcontroller has its own specifications, and I suggest depending on what you use it for, before you start with the project, you have to choose which microcontroller you want. And that is also an important part when you're creating your project, to choose which board you require.
So do we power this microcontroller through an external power source, or?
Yeah, this is usually connected to your PC.
So it works only when we connect it to our PC.
Yes, or you can provide it with a battery here. Over here, you see this pin.
Okay.
You can connect. You get an adapter for this, and you can connect it to a battery as well.
All right.
And it will retain the code.
All right.
Yeah. So
you can also do it through the VIN pin. Na?
VIN. Yeah, you can also do it through the VIN. So is everyone done with this? Shall I start with the coding part?
Yeah.
Okay. So once you click on code on the right hand top corner, you'll be presented with the screen. So we'll be writing it in text because it's more practical, and when you do actual projects on the Arduino IDE, you'll be using text itself. These blocks are available for beginners to learn better on TinkerCAD. So when you open code, click on the drop down box and select text, and it'll ask a pop-up box will appear. Click on continue. So everyone should have this visible on your screen right now.
But this says C++, so won't C work on this?
The Arduino IDE uses its own language based on C and C++. It's a mix of both. You can't actually call it either of them.
Okay.
But it's based on C and C++. Okay. So I'll be deleting this code, and I request you guys to do the same. So now we first have to define which pin of the sensor is connected to which pin of the Arduino. So the first thing we do is use a command called #define. So what #define does, it allows the programmer to give a name to a constant value before the program is compiled. So we are defining a variable called echo pin. I want you guys to type with me because it'll be better. So define echo pin, and as it is connected to the second pin on the Arduino, this is what I told. That's why I connected it to digital pin 2. I'll be writing 2. If any of you have connected the echo pin to any of the other pins, digital pins, I request you to change this to that number. It doesn't matter which of the 14 you've connected it to, just change it over here. So we define the echo pin, and we define the trigger pin as well.
Is it a #define echo pin?
Yeah, it's #define echo pin. #define as a command. Okay, and to calculate the distance using the formula Prakriti told, that's this distance will be duration into speed by 2. So we'll be introducing two variables using int duration. Int is a variable. You're defining the variable duration. So you use int and you use int distance. We'll be using these two variables to perform the calculations and derive the distance from the readings of the sensor. Okay, so after this is done, we go to void setup. So any Arduino program basically has two main parts, the void setup and the void loop. The void setup is where you tell the microcontroller which pin works as what. So here we'll be defining the pin using a command called pin mode, and we'll be telling the microcontroller that the trigger pin is an output pin. Means it will be sending out the signal, right? So we define the pin mode as trig pin output. And yes, if you want more information on the codes we are using, that's pin mode and all, I'll provide the link to a website and after this project, and you can go look into it after this.
Next to the void setup, is there curly brackets?
Yeah, there's you open the there's a curly bracket here. You open the loop void setup part here using the curly bracket.
Okay.
Yeah. And you type in pin mode echo pin input because it'll be receiving the input. So everyone's following till here. Any doubts?
No.
Okay. So next we initialize the serial
Yeah,
communication.
I had it out.
Yeah.
Yeah, the pin mode is a keyword, or is it like a new function that we're
It's
defining?
a keyword. It's basically a function provided by the IDE itself. And
Okay.
if you want to learn more about it, uh, I didn't want to interrupt this, but you can go to arduino.cc. I'll just type it here, but this is not part of the code. Arduino.cc, and there under documentation or references, you can find each and every one of these commands and what they do.
Okay.
Okay, so next we initiate the serial communication between our Arduino and our computer using serial.begin. This usually initiates the serial communication, and we provide a number 9600, which is usually called the baud rate. So it's the maximum data that can be transferred between the computer and the microcontroller, and it's in bits per second, and it's called baud rate, and it's of high significance, and you can go read on it later. So once we are done with the setup part, we close the setup using another curly bracket, and then we enter something called void loop. So the commands in the loop keep on repeating. So whatever part of the program you want to keep repeating, you can enter it in the void loop. So you type void loop, two open brackets and one curly bracket. Then you use digital write brick pin low. So what this does is that in case the trigger pin was active before, we are shutting it off here so that there's no miscalculation due to another ultrasonic wave coming back. So first we turn off the trigger pin and give a small delay in microseconds.
Can you just explain that once again? What you?
Yeah, okay. So digital write trigger pin. So in case the trigger pin was active before and it had sent out it's sending out ultrasonic wave, we don't want it to hamper our calculations by those waves coming back, right?
Okay, okay.
So we are making sure it's off. So we are writing low.
Okay, understood.
Yeah. And we give a small delay of 2 microseconds. And next we activate the digital pin now. The trigger pin now using digital write trigger pin high. And we'll give a delay of 10 microseconds. Is everyone following till now? Should I stop at any point?
What's the use of these delays?
The delays is the time, like the trigger pin is active and we are sending out the ultrasonic wave for 10 microseconds. Once the delay is over, it goes on to the next command what we give. So it's just a time gap.
Okay.
So next we turn off the trigger pin now using digital write trigger pin low. And now we take in the first reading. The first variable we set up was duration. So to get the duration of how long the wave traveled, we use a function called pulse.
It should be digital write trigger pin, na?
Yeah.
Above
yes,
side.
yes.
Yeah.
Okay. So we use a function called pulse in. Okay, it's specialized to this sensor, and you can look more into it on Google or on Arduino, on the Arduino website. So we take pulse in, echo pin high, because echo pin will be the one on the sensor which gets to know that the echo has been received. So we use a function called pulse in here. Next, now that we have the duration, we just use a simple conversion to convert it into distance. So we've already defined our variable distance. So we just convert using the duration. We multiply it into 0.0343. That's the speed of sound in air by 2. By 2, as Prakriti explained, because it has to go and come back from the object. So we
What
divide
does
it by
pulsing
2.
do?
Pulsing basically measures the time the echo pin is active, the time it takes to receive the ultrasonic wave. So that gives
And
us
what
the
is the
duration.
high in the pulsing?
Yeah, during the time the echo pin is high, that means the echo pin is sending out an electric signal. When the receiver receives a signal, it sends an electric output through the echo pin. So it's reading that value, echo pin high, the time during which
Okay.
the echo pin is sending a signal. So next, we've calculated the distance here. Now all we have to do is just print out the distance. So for this, we'll be using the command called serial.print. Serial.print basically prints out the whichever variable we want on the serial monitor. So we type serial.print and just gonna type in distance. Now we taken the value of the actual variable. So we type in distance. And the output will be in centimeters. So I'm just printing that as well. And to go to the next line on the serial monitor, we use a command called serial.println, which takes it to the new line and centimeter. And I'll give a small delay. So I hope everyone followed till this point. If you have any doubts, you can ask me. I'll wait till someone tells yes that they've completed writing the code.
What's the serial dot print ln in the bracket?
Here in the bracket, that's centimeter.
Okay.
CM. I've just written CM. Yeah.
I think you have not closed the bracket after 1000.
Yes. Thank you. Is everyone done till here? Any other doubts? If someone has a doubt, you can ask.
I think I asked this before, but
Yeah.
I can't see properly. But so
Yeah.
next to void loop, there are two curly brackets and one flower bracket, right?
Yes. I mean, two normal open brackets and
Okay.
the opening of a
Square
flower
bracket.
bracket. Flower bracket.
Sorry, flower bracket. All right,
Yes.
all right. Thanks.
The delay is in microseconds or milliseconds?
This 1000, I think it's 1 second, so it's in milliseconds. Delay. Delay is in milliseconds. When I write delay microseconds, I have to write delay microseconds.
What is the default unit for delay?
Milliseconds.
Okay.
Okay. Is everyone done till here?
Yes.
Okay. So I'll click on start simulation. And if there's no error, it should start the simulation and this will turn green.
Sir, can you wait for 2 minutes?
Yeah, sure.
The define echo pin and trick pin, are those header files?
Yeah, I know they're not header files as such. Like I told, hash define is just to let the microcontroller know that these are constant values and they won't change.
Okay.
So, are you done writing the code?
Yes, sir. Done. Thank you, sir.
Yeah. Okay. So, like, if I have some error here, this didn't have any error, but if I do create an error here, miss out a bracket or anything, this will let me know, or like which line has the error, so I can just correct it that time. Okay. So, if any of you are having an error, just let me know. So yeah, once we click on Start Simulation, the this will get connected, and you can see a green light on the Arduino Uno. And then you can open the serial monitor below, and it'll be typing out results at a second gap. So now we are getting a few results. Now to change the distance of the object, like to visualize how it might be in real life, you have to click on the sensor here on the ultrasonic sensor, and you'll get something which looks like this. So when you move this object around, you can see the values will be changing on the serial monitor. And this is the basic use of an ultrasonic sensor, that is to sense distance. So is everyone getting this output?
If you see, there is sometimes some variations are coming, like 149, 150,
Yeah,
140. What
yeah.
is the reason for that?
I'm also not sure of the reason, because this is a simulation and it shouldn't happen. Like if it happens in real life, I can tell it might be because of some connection issue or something. But in this case, I think it might be because of the delay or something. Because
Okay.
we've given a 1 second delay, right? So if
Yeah,
I
yeah.
move it randomly pretty fast, there might be a small error in between.
Okay.
Yeah.
My serial monitor is not showing any output.
Okay. So could you share your screen?
Yeah.
Yeah.
Is it visible?
No, it's not.
For me, in line 18, it shows an error.
Okay.
So after
After
refreshing
the
screen,
run, then you can
yes.
Yeah. Can you see it now?
Yeah, it's visible. Yes. Yeah. Okay.
The simulation is on, but still I'm not seeing any results.
So yeah, okay. I think I see the error. Can you zoom in on the this side, please? Yeah. Click on your ultrasonic sensor. Okay, wait. Click on serial monitor below.
Oh, okay.
Yeah. Okay. Yeah. Now click on your ultrasonic sensor. Yeah.
Yeah, it's still not showing.
Yeah. Just give me a minute. You scroll down on the right hand side. Even I'm not sure what's happening here. Could you take distance
Sir,
to the next?
simulation time is also means 0000.
Yeah, it will keep. Yeah, it's 000. That's what I'm saying. Can you stop the simulation and start it again?
You have done that.
Yeah, I think there's some problem with the simulator itself because even the timer is not starting, like someone pointed out.
Should I
So
give it a
that
try
might
later?
also. Yeah, sure. You can give it a try later because even I'm not sure. Like if the simulator time
Due
was.
to the third line of code, like we defined duration and distance. I think what you said is a bit different. Like I given 2 lines.
Yeah, I just
Yeah,
gave
but
it another, but that
yeah,
shouldn't
you can write
affect.
in one
That
line.
is not a
Yeah,
problem.
Difference. Okay,
that's
I
not
wasn't
the
sure.
problem.
That is why. Okay.
Yeah, it's
Fine.
okay. That's not the issue, but
Okay.
even the simulated time has not started, so it might be a problem with the simulator itself in this case.
Okay, I'll just give it a try later then. I think this will be a
Yeah,
waste
I'll
of
be
time.
sharing the codes later, so you can also
Yeah.
try it later. Yeah.
Sure.
And Logesh, yeah, you can share your screen.
Yes, I'll share my screen.
Yeah.
Yeah, can you see my screen?
No, nothing's visible. You'll have to choose share entire screen.
Okay.
Yeah.
Yeah, actually, I got it now. That the simulator
Yeah.
had a
Okay.
lag issue.
Okay.
It's 104 centimeters always.
Yeah, and you can change. I told you, you can click on the
Yeah,
other
you
side.
can
Yeah.
change the object length and
Yeah. It's capital I. That's it. Just capital I. Pulse in. It's a capital
Where?
I.
Oh, okay.
And no, just change that, and we'll see if there's some other error.
so the syntax is like a little bit different from C and C++ on
Yeah,
Arduino, right?
it's its own language as such, but most of it you'll understand once you read C and C++.
So it's
A
not
few
case sensitive, I guess.
It is. Like the commands will be case sensitive, right? The language
Okay.
is not, but the commands
Right,
will
right.
be.
Right.
Yes, so yeah, the simulation is working for me right now. Thank you.
Okay, fine. Yeah. Okay. So let's have another small demo on an analog sensor. Is it fine with all of you? Or is it a
Excuse
little
me,
late?
sir.
What? Yeah.
So
Yeah.
I have it shows an error in my line. Shall I
Okay.
share my
Yeah,
screen?
you can share your screen. Yeah.
All right. It shows an error in my line 22. This line.
Can you click on start simulation once? Okay, I think you put print 1N instead of print LN. It should be L
Oops.
there.
All
Yeah,
right.
it should be L there. That's it.
Okay.
That's the English.
Thank you.
So I'm planning to show another analog sensor. Is it fine with everyone? Or is it a little late?
Yeah, it's fine.
Yeah,
I
okay.
guess so.
Fine with me also.
Yeah, okay, fine. I'll be sharing my screen. So now to exit this, you can just click on TinkerCAD here on the left top corner. Stop your simulation and click on TinkerCAD. And it'll take you back to the home page. So now we'll create a small little circuit on the photoresistor or the light dependent resistor, LDR. So yeah.
Sir,
Yeah.
sir, I have a little bit doubt. Can I share
Yes.
my screen?
Yeah, sure. Harsh, can you
Yes,
please?
sir. I
Yeah.
am sure.
Yeah. Yeah. Yeah, you've not closed it with a semicolon at the end of the code.
Sorry, sir.
At the end of the code, you need to give a semicolon. At the end of the line, serial.print distance, semicolon at the end. At the end of every line, there should be a semicolon added.
Okay.
Yeah. And I think you've given serial.print capital IN, it's actually LN. So just change that as well. Yeah. And even on the distance line, you've not given the semicolon. You could give that as well. Not there, above that.
Line number 20.
Yeah, that's it. Yeah.
Thank you, sir.
Yeah, okay. Now, because we have less time, I'll just take one session on the light dependent resistor. We'll create a small circuit. Okay. I'll just share my screen now. I'll be providing all of you with the codes as well later on if you want to try it. If you want to try a few more, I've included the gas sensor and PIR sensor as well. So you can go through that after the session. So now to create the circuit for the LDR, we'll basically be making a daylight sensor of sorts. So first we take our Arduino Uno. Next we take an LED. We take an LDR. In this case, it's called a photoresistor on TinkerCAD. So you'll find it under the name of photoresistor. We take that. And we take two normal resistors. So has everyone got the components required? I'll wait for like a minute. So you guys can bring the components onto your screen. Did everyone get the components onto the screen?
The photoresistor itself is the sensor, right?
Yeah, it's the LDR. Yes.
So just a minute.
Yeah. Did everyone get the components?
Yeah.
Yeah. Okay. So now, first thing we do is connect the cathode of the LED to ground. Same way, we join the wires. So the cathode through a resistor will go into ground. That's just to reduce the current passing through the LED. Okay, and then we connect the anode to pin 13 on the Arduino. And for the photoresistor, we connect one terminal to 5 volts. And the other terminal, we connect it through the resistor to ground. And
can you zoom in a little bit on your board?
Yeah. Okay. Is it fine?
Yeah, this is fine.
Yeah. So one terminal to the 5 volts, another terminal through the resistor to ground. And from the terminal which is going to the ground, we take one more wire and connect it to A0. As it's an analog sensor, we'll connect it to the analog pin on the Arduino. In this case, we are connecting it to A0. So I'll just wait for a minute for everyone to get done with the connections and we'll move on to the code.
How do I delete the wires? I just pull one.
Okay, so you can just click on it and you can click on delete on your keypad, or you can use this dustbin symbol on the left hand top corner. Either one works. Got it?
Yeah, I got it.
Yeah, okay. So is everyone done with the connections?
Actually, I'm
Yeah.
not able to take the connection from the same wire and connect it to the analog port.
You shouldn't take it from the wire, you should take it from the terminal. Click on the terminal and connect it to A0.
Okay.
So here it gets highlighted, right?
Okay,
When
okay,
it's highlighted,
okay.
you take it. You
All
take
right,
the
all
wire.
right.
Yeah.
I'll try it out.
Yeah, if it still doesn't work, you can always share your screen. So is everyone done with the connections?
Yes.
Okay. Now click on code and go to text like we did the previous time and delete whatever is present there. And everyone should have this visible on the screen right now. Is everyone here on the text part?
Yeah.
Okay. So now the same way we first define what pin is connected to what. In this case, instead of define, I'll be using something called constant int LED pin. So I'm just doing the same thing, but instead of define, I'm using constant integer as constant, and we'll be giving it as LED pin 13. And same way, const int LDR pin, A0. So if you want, you can always give a random variable X or Y as well here instead of LED pin or LDR pin, but it's just more convenient when you look back into the code later. Like you'll know what is doing what. So once you're done with this, we move on to void setup. So void setup is a void setup, two open brackets, one and then one flower bracket. And then we initialize the serial communication between the Arduino and our computer. Serial begin 9600, the baud rate. And then we define what each pin will be doing. So the LED pin lights up the LED. So of course there will be an output, while the LDR is taking an input. So we'll give it as input. And then we close this setup and I'll wait for you guys. Is everyone done till here?
Meanwhile, can you please repeat why you gave 9600 and line
Yeah,
5?
okay. Yeah, so 9600, right?
Yeah.
Yeah, okay. So 9600, as I stated earlier, is a baud rate, okay? So there's a particular set of values you can give to each board. More info on that you can find on the arduino.cc. For the Uno, it's 9600 and it's the maximum rate at which data can be transferred between the Arduino and your computer. And it's the microcontroller is usually based on that number itself to usually work on that rate of transfer.
Okay.
Yeah.
Is it serial dot begin?
Yeah, it's serial dot begin open
Okay.
bracket 9600. Next we go into the loop part, void loop. And here I introduce a variable called LDR. So int LDR analog read, because it will be reading the analog input of the LDR. So analog read LDR pin, which is nothing but pin A0. So now once we have the reading, we can do a simple if else statement here. If the reading of the LDR is less than equal to 500, we'll turn on our LED, which we'll do by typing digital write LED pin high. And we, just for our confirmation later on, we can print out the LDR reading. And once we are done with the if statement, we'll put an else statement. In case LDR is greater than 500, digital write. And we turn off the LED because there's enough light or enough light intensity. So we can turn off our LED pin low. And just for our confirmation that it's working properly, we print out the value of the reading, serial.print LDR. Then we give a small delay of 1 second between values. And we close the void loop. So yeah, I'll wait for everyone to reach here. Yeah, so this is a simple code for a daylight sensor, if you will, if you want to use it later on. So yeah.
What is the meaning of value 500?
The reading of the LDR, we just when it gives the output, we are keeping it when it's within 500. So
Okay, it is the intensity.
range, yeah, the light intensity. Yes.
Okay.
Yeah.
Is the 500 the delay? Like,
No, it's not the delay. It's the light intensity value. We are keeping it when the light intensity is below 500.
below 500, like what units?
It's not exact units. Like it's not the proper units of light intensity. It's the readings of the Arduino basically.
Okay.
I can't tell the like it doesn't have exact units.
Okay.
So in this code is are certain commands case sensitive, like digital write?
Yes,
Does
digital
W
write is a function, so W has to be
to be
capital.
capital?
Yeah.
The same goes to analog read.
Yeah, same goes to analog read.
All right.
Yeah. The variable names, you can keep them whatever you want. But when you use the functions, built-in functions, you have to follow the syntax.
All right. All right.
Yeah. So I'll just wait for one more minute and I'll click on start simulation.
Sir, what is the use of delay?
Yeah, like I told, if I don't give a delay, it will keep sending us continuous values in the serial monitor such that you won't be able to read also. By giving a small delay, you can keep a gap in the readings. Even if you don't give it, it's fine in this case. In the previous case of our ultrasonic sensor, it was necessary because we were deciding how much time the pulse is going and coming back. But in this case, it's not necessary.
Okay.
Yeah. So once all of you are done with the code, just click on start simulation. And here I'm getting a reading. LN here so that it prints in a new line. So right now it's giving us the value of 6 here. So anyone can tell why I used ln here, what the difference was. It's just printing it in a new line here. So that's the use of ln. Instead of getting values in a straight line without any spaces, you get it in a new line. So that's the only use of ln here. So once you complete the code and start the simulation, you can see the LED is turned on because it's printing a value of 6. When you click on the LDR and increase the light intensity to more than 500, the LED will switch off. So if anyone is doing the simulation getting any error, you can share your screen.
Can you repeat the last part again?
Okay, so last part meaning the working.
Yeah, why the LED is on and
Yeah, so as per our code, we had written if the value it receives is less than 500, we told digital write LED pin high, which means we are turning on the LED. So if I reduce this below 500, say a value like 425, it will be turned on as per our code. So if I increase it above 500, it will turn on.
Turn off. All right.
Yeah, because we wrote else.
Since the LEDs of red color, are there different colors available?
Yeah, you can just in real life, yes. Even on TinkerCAD, if you just click on the LED, you can change the color here. There's a drop-down box available. You can change your color.
All these sensors will have a certain limit, right? Up till how much it can
Yeah,
measure.
yeah. So for this, you'll have to refer to the data sheet of whichever sensor you want particularly, and there it will be written the voltage values on which it will work and what resolution it can give, what range it can give. Yeah. Yeah. Hello.
So these values on the serial monitor is actually the light intensity falling on the
Yeah.
LDR, right?
Yeah. Yes.
All right.
But how are you getting 613 when we set the limit to 500?
We aren't setting the limit to 500. We are just telling it's an if statement. It's not a condition here. We are just telling if the value you are getting is less than 500, turn on the LED. We aren't restricting the value to less
Okay,
than
but the
500.
output will just give whatever intensity is being.
Yeah, it'll give whatever intensity it's receiving.
Okay.
So if anyone has any error, you can share your screen. By that time, Prakriti, you can share the drive link of the video as well as the codes. And is anyone using wants me to share my screen right now? That's still writing the code. Just let me know. I'll share my screen.
In this drive link, there is a PDF of the codes which Aditya just wrote and a video of how the ultrasonic sensor works, like while connecting it to the laptop. You can see how it really works.
Yeah, and also we didn't dive deep into what an Arduino or Arduino Uno is or the coding part of it. I just gave you a few functions and we wrote them. But we'll be having another session on 10th October at 5 p.m. all regarding Arduino. So if anyone has more doubts regarding the Arduino and how to code it, you can attend that session as well. So yeah, thank you all for attending. If someone has any errors, I'll be accepting them now. And I'd also like to show a small mini project. I think someone asked regarding a smoke sensor. So I have a small project on that. So I'll just share it with you. So for this project, I've used a TMP36 sensor. That's a temperature sensor we use, as well as a gas sensor to act as a smoke detector. So when I start the simulation, when there is smoke as well as the temperature is pretty high, the buzzer will start to buzz, and yeah, it'll start to buzz. It'll start to buzz, and the door will open. So this was a very basic project I tried by integrating two sensors. So using the code I've provided in the drive link, even you guys can try these out, mini projects, and I'm pretty sure this is the best way by doing projects to start learning more about Arduino. So I encourage all of you to start making mini projects using a single sensor for now and then slowly integrating one or more sensors. So yeah.
So the link for the 10th October class will be again sent through email.
You'll have to register for it on VTalk and then you'll be receiving the mail. Yeah.
Okay.
Yeah. It'll be available and it'll also be sent to you via the usual student welfare mail. The mail you get today's events, even in that the meet link will be provided as well.
Okay.
Yeah.
Thank you.
Is there any website or any place online where you would suggest for learning the codes used in Arduino?
For anything, www.arduino.cc is the best place to get all functions, like to get to know the functions. But to start learning it, you can go through a few good playlists on YouTube. You can find them on YouTube, and those will also help you learn Arduino better. But like if you don't understand any function, if you don't understand what some code is doing, the best place to go is Arduino.cc.
All right, thanks.
So on 10th, what will you be taking?
So on 10th, I won't be taking the session, but it'll be on the basics of Arduino, what
Okay.
the Arduino board is, what are its components, the timer, like the PWM pins I didn't explain today. Those will be explained there. Analog pins, digital pins.
Okay.
So all those.
So it will come
We
in what
also
I
need.
registered today only, na? Where I registered in VTop.
Yeah. It will be there also.
Yeah. Okay.
Also, you will get to learn projects. Like it will be a live project demo, just as like how Aditya was explaining to people. That also will be there.
So I request all of you to keep the drive link with you, because once this meeting goes, the drive link won't be available. So you can just bookmark that drive link to use it for like to view the ultrasonic sensor, as well as keep the codes for a few basic sensors. The other thing you can do is go to Google and search for each sensor. You'll get the data sheet as well as basic Arduino code for it. Almost every sensor usually has an Arduino code written on one of the Arduino query websites, so you can look into it. And yeah, like I hope you all enjoyed this session, and thank you for attending. If there are any doubts you're having, any errors, you can share it now.
Thank you everyone for attending this session. I hope you all gained something out of it. And if you want to learn more, you can go and search it for yourself. Thank you.
Thank you, sir. Thank you, ma'am.
Thank you.
Thank you.
Thank you, sir. Thank you, ma'am.
Thank you.
Hello.
Yes, Sanjit.
Yeah, this is hosted by the IEEE chapter, right?
Yeah, this is by IEEE SPS, the Signal Processing Society.
Okay, I wanted to know, so the chapter is fully, like all these events that you host is fully done by the
Yeah.
students itself?
Yeah, it is done by the students themselves.
Okay, and what does IEEE have to do with this?
IEEE SPS is a part of IEEE which deals with signal processing, and it's a club in VIT, and we take basic electronic, like we introduce you to basic electronics, and then we also help you with signal processing later on, like projects related.
Yeah, actually, IEEE Space is a big organization. Like in each city, there are groups which, as researchers, doctorates, etc. So IEEE Space is everywhere basically. So with VIT, we have all the clubs and chapters, right? So IEEE Space has come forward and like tied up with VIT and started a chapter for the students, which is totally managed by the students at VIT, and that is how IEEE Space VIT is formed and like it is started.
Okay, thank you so much.